Record. Welcome to our third week, and we're reviewing food preparation. We've done the recipe scaling, but not much else. So we started recipe scaling by talking about ratios and proportions. A ratio is something like 40 miles per 1 hour. And a proportion is when you have two of these ratios with an equal sign between them. And we did a whole lot last time about how to set these up. And when you're taking a word problem and you turn it into a proportion, what's the right way to do it? And we decided that the ones that work the best have the situation for one situation on one side, like 40 miles in 1 hour, and the other situation in the other side, like 80 miles per 2 hours. And that way we can make everything symmetrical. If miles is on top, it has to be on top. If hours is on the bottom, it has to be on the bottom. And that way we really can't mess up. The whole reason to do this is it makes a fail-safe thing where we can cross multiply and the math tells us when to multiply and when to divide, so we don't have to guess and maybe get it wrong. Another reason to use proportions besides scaling the whole recipe from this many servings to that many servings is when you have to change units of measurement, like 16 ounces is a pound or 4 quarts is a gallon. And we talked about the ways to memorize how many cups or pints or quarts are in a gallon. Anyone want more review of that?
Yeah, I'll have some review.
Okay, so what I'm going to do then is actually get a new, whoops, why didn't it work? Let's go to some random problems and do that. So I'll write metabolism random problem so people looking at this later know what we're doing. Okay, so again, we have two situations. We're going to put one of them on the left. You don't actually, in your work, label them like this, but I'm going to, that's going to be too far because I'm lecturing. So the first situation was that 1 gallon weighs 8.6 pounds. And at this point, don't write what I'm writing anymore. The other side, we need to have the words match. But if I try to keep going, it says, again, don't write this, 12.5 cups is how many pounds? So the pounds match, but the words on top don't. So we need to either get rid of the cups and make it gallons, or get rid of the gallons and make it cups. Make sense so far? So we could do either. It's probably easiest to get rid of the gallon and make it cups, because we can look at that picture here and see that a gallon is 16 cups. So let's do that. We'll take out the gallon and cross it out, and we'll say instead it's 16 cups. And now we're good. So if you've been waiting to write things because I told you to, then now we can write this. We have cups on top and it matches. We have pounds on bottom and it matches. One situation is on the left side, the other situation is on the right side. There were two ways to do this. So let me start a new slide because I'm sort of running out of space at the bottom. So 16 cups and 8.6 pounds, 12.5 cups, and how many pounds? So we could do this with cross multiplying, or we could use a shortcut. The cross multiply method says that I'm going to multiply like an X shape and set each of the X diagonals equal to the other. And I can pick which goes on the left and which goes on the right. So I'm going to pick, whoops, let's make that a highlight. So I can pick this one to be on the left. And when I do that, I can also pick to put the y first, because y times 16 and 16 times y are the same. Everyone okay with setting that up? Okay. So that becomes y times 16. And what is 8.6 times 12.5? 107.5. And I'm going to divide both sides by 16 to get y by itself, because the opposite of times 16 is divided by 16. And we'll get about 6.7 pounds. Does that seem reasonable? When we get an answer, let's check it. So this is 4 fours. This is roughly 3 fours. So this number should be about 3/4 of that one. Yeah, that looks reasonable. I think we're okay. The shortcut said that the ones that don't have the y, you can multiply. Let me make that a. And then the ones that do have the y, that number you divide. So we'll say that we'll do the 8.6 times the 12.5. And then we'll divide by the one opposite the y diagonally. And that gets us the same answer more quickly. And you can see it's the same thing. First we multiplied these two, and then we divided by the 16. And we talked a bunch, not yesterday, on Friday about why you would want the shortcut or you don't want the shortcut. And the summary is that if Math 25 is your last math class, you can get in the habit of always using the shortcut. If you're going on to Math 60 afterwards, then if this y was something a little more complicated, like a y plus 1, then always using the shortcut might make more work for you once things got a little worse. So if you're going to see the Math 60 kind of math, don't rely on the shortcut. Get in the habit of using the cross multiply method. But if this is your last math class, go ahead and do the shortcut. Okay. Where we stopped on Friday was talking about measuring spoons. Some other conversion rates that work just the same is that 3 teaspoons is a tablespoon and 16 tablespoons is a cup. So we can do problems like these. A restaurant recipe makes 30 servings and requires 2 cups of butter. So I can just start writing that as a proportion. 30 servings goes with 2 cups. I know even before I finish reading that I want to have servings on top and cups on the bottom. Something might mess me up like we had before. I might have to change one of these, but that would make things nicest. If we had one situation on the left and one on the right and the same words on the top and the same words on the bottom. So now we'll keep reading. You want to scale the recipe down to make 6 servings. How many tablespoons of butter will it have? So it asks for an answer in tablespoons. So we have 2 choices here. We could either say, let's do all the math in tablespoons, and the first thing we want to do is take the cups and change it. Or we could do our proportion in cups, get an answer in cups, and then as part 2 of the math, change it to tablespoons. Anyone have a preference which way we do it?
Let's do tablespoons.
Make everything tablespoons. Okay, so I will here grab these. So what am I going to change my 2 cups into?
$32 tablespoons.
Yeah. So we'll just do that. Now we have 32 tablespoons. And this is also in tablespoons. So now we have the math matching. We've gotten to tablespoons right away. We don't have to do any fidgeting at the end. You want to do cross multiply or a shortcut?
Cross multiply.
Okay. So we have y times 30. I'll pick the diagonal with y first, and I'll write it, the y first, just because my brain likes that. Whoops, not 2. We changed it. Now it's 32. Okay. We have a times 30, so the opposite is going to be divided by 30. And we get 64, 6.4. So we can round it. And with recipes, real life is a little more vague. Do I want to round up or down? It's more a matter of taste than accuracy. Do you want to be slightly more buttery or slightly less buttery when you're making your thing? So I'm going to pick 6 tablespoons because traditionally we round down with 0.4. But if you round it up to 7, then you could defend that just because you like the recipe more with slightly too much butter instead of slightly too little.
It's cheaper to round down.
My wife adds, it's cheaper if you round down. Yeah. Add in the bubble so it doesn't mix things up. Okay, questions on this one? A question I'm surprised no one has had. Let me go back to zoom in on this. At one point on that last slide, we had y times 30 is 192. And usually somebody asks me, you wrote division on both sides with an actual division symbol. I was taught to instead make like a fraction bar. Is that okay also? And the answer is yes, that's also okay. And one moment, let me pause. So the only problem with the fraction bar, because fractions and division are pretty much the same thing, is that if you had a different equation that was already full of fractions, it gets to look a little weird. So if you had something like y times 3/2 is 15/8, then if you wrote that with a fraction bar, especially if you didn't have 2 different colors, that gets to be sort of just this confusing totem pole of numbers stacked on top of each other. Whereas if I write it with the division symbol, then that might look a little nicer. So just for that special case where we have fractions, I'm in the habit of using the division symbol because it looks nicer in that one case. If you don't have a habit, then might as well get the habit that always looks good. If you're used to the fraction bar, you can keep doing that. This doesn't happen very often, so you can manage. Okay, back to our lecture. If we take a portion of cups and turn it into tablespoons, what happens? Oh, okay. We can solve this just as we've been doing. We want a proportion. In general, is one situation. And then our problem is the other one. Oh.
Oysters.
So in general, we have 16 tablespoons is 1 cup. In our problem, we have 0.2 cups. And we're wondering how many tablespoons. Everyone happy with my setting things up? So I'll cross multiply again. Oops.
I know you're stuck in just a minute, but when you're done with that, can you please take all the pencils downstairs because I was stepping on them trying to turn off your tablet.
Okay, questions about that one?
Nope.
Okay, is this answer reasonable? If we had a whole cup, we'd have 16 tablespoons. We just have 0.2, which is a fifth if you know that, but a small part of a cup. So we have less than 16. Yeah, that makes sense. Okay, so here's the clever little bit. On 31, oops. We can take 3.2 cups and change it into 2 parts. We can have the 3 cups and the 0.2 cups. The 3 cups just sticks around. And then the 0.2 cups, we do what we just did, right? 0.2 cups is 3 tablespoons. So just be aware that sometimes that's the easiest thing to do, to sort of peel off the whole number. It just waits around, convert the decimal into what it asks you to do. Okay. That's changing topics. Anyone want me to do more proportion kind of things? No? Okay, I guess we're good. So there's sort of 2 flavors, just pay attention. One is when one side of the proportion is just your general conversion rate. The other style is when there are 2 real situations, because I'm scaling a recipe or something like that. Okay, moving onward. Here's a tricky problem. I'll have you try it first, and then I'll reveal the answer. As a birthday present, Janice receives a $50 gift certificate to a favorite fancy restaurant. and she invites her friend to join her for dinner there. And they're going to pay 25% for tip and tax. So she's wondering how much she can order. What's the most she should pay just for the food if she wants the total to be 50, including the tip and the tax? Any ideas? Okay, here's a hint on what lots of people try that doesn't work. So a lot of people will say, I'm going to start by finding 25% of 50. Have we done this kind of percent sentence before? I don't remember what we reviewed. Yes, we have. Okay, so I can just translate that. What becomes y is becomes equals. For my percent, I'm going to riplop because my calculator likes decimals. I'll go left out of percent and get 0.25. And 50 stays 50. So it looks like she can spend up to $37.50 and still be okay with the tax and the tip. But this number is actually too small. If we ask, what's a quarter of this? What's 25% of this number? Then we get something that's less than $12.50, because this is a smaller number than the 50. Right? 25% of a bigger thing is going to be more than 25% of a smaller thing. Just like if you have 10% of my income, that's a lot less than 10% of Bill Gates's income. So somehow this percent sentence, what is 25% of 50, led us astray. So let's ask a different percent sentence. So we're wondering if you pay for the food and the tax and tip. So that's going to be 125%. Then what amount? I'm sorry.
Can you explain
Amount.
that 125%?
Where did I get it? Because I want the 100% of the food and also the tax tip combo. So I'm trying to ask $50, my gift certificate, is equal to, will cover the 100% of the food and 25% more of the food. Does that then make sense? Did I use enough explaining? So now I translate. Again, I'm going out of percent. I have something stuck onto y with times 1.25, so I'll do divided by 1.25 to both sides. And we get 40. And now you should be able to kind of see it working in your head. Oh, of course, 25% is a quarter. A quarter of 40 is 10. The 40 plus the 10 makes the 50 with not any wiggle room. So an incredibly tricky problem. Almost everyone that you give the problem to does it this way first and gets an answer that's slightly too small. So the moral of the lesson is that the same percentage, 25% of a smaller number is smaller. The same percentage of a bigger number is bigger. 10% of my income is less than 10% of Bill Gates' income. So now that that's really stuck in your head, we'll keep going. So the last part of figuring out how much to shop for in a restaurant kitchen is called yield percent. And by the way, did you know after removing the pit, if you cube the avocado, it pops out of the skin easy? So imagine someone buys 100 pounds of avocados, they peel and pit them, and find out that they have 79 pounds of usable stuff for cooking. And at this point, there's a momentous event in history. What do we do to talk about this? What do we do with the 100 and the 79? We could start from the point of view of the shopping. We say that the shopping amount is the original amount. That's what we had first, sitting on the counter. And then trimming gives us 79% that's usable. Or we could start from the point of view of the usable ingredient. We can say that the recipe wanted a bunch of trimmed avocado. So when we're shopping, we have to buy extra, more than 100%. And we could do the 100 divided by 79 is 1.27 and say that we need to buy 127%, more than the recipe calls for. Both of those options would make sense. There's nothing about real life or grammar or math that makes the shopping count as original or recipe amount counts as original more meaningful. However, historically, the culinary industry has made a choice, so we have to follow that. And they choose the first option and name it the yield percent. So if you buy avocados, then on average, you'll get 79% of the weight that you actually put in the pot and use in your recipe. This should look vaguely familiar because we had earlier in the term this table. And we talked about how the numbers for calories per minute per pound when exercising are just estimates. If I bicycle up a hill, it's different than if I bicycle on the flat ground, which is different than if you bicycle in any way. So exactly how many calories people burn per minute per pound, we don't know. We just have to pick some number to use it in the math class for the homework. And if you were actually someone who cared about this, your personal trainer might be able to find the more accurate number for you. So in a similar way, these yield percents are not 100% accurate. How I trim carrots will be different than how you trim carrots, and it might depend a little bit on the carrots. But we need a number to use. So we're just going to all pretend that these percentages are accurate and say that, yes, when I buy celery, I get 69% of it usable after I trim it and take off all the bad spots and leaves and things like that. There are other tables of yield percents available online. I give you links to 2 of them. And there's also yield percents for meats, and I give you a link to that. But we're ignoring the ones for meats because that's really dependent on lots of things. Maybe a culinary class would get into that, but a math class will not. So let's do that kind of example. Okay, so the restaurant buys 100 pounds of potatoes. We trim the potatoes, so we go down over here and say that for potatoes, it's 78%. We can use some riplop. Go left out of percent. And unsurprisingly, since we started with 100, we get 78 pounds of trimmed potatoes. So that kind of yield percent is easy, which is why the restaurant industry picked that. Unfortunately, the more interesting case is usually going backwards. So we now have 100 pounds of potato that's trimmed. If we multiply it by the 0.78, we're going to get an even smaller number. That's like we're double trimming our potatoes. So we want to do something else instead. What should we do that's the opposite of a times 0.78?
When you go from percent to decimals, do you just move the decimal point like over to?
Yep, it's always 2 scoots. And rip-flop means if you're going out of percent, go left. If you're going into percent, go right.
Okay.
So right into percent, left out of percent. So what do we do with this number since we can't multiply? Yes, in the chat, somebody suggests dividing. If I divide by 0.78, that makes it bigger. So now I get about 128 pounds. So this is what we will do more often, because this is the more realistic thing that you see in your recipe. My kitchen needs to make a Thanksgiving meal for a huge crowd. We're going to need 100 pounds of potatoes. But if we only shopped for 100 pounds of potatoes, by the time we trimmed them, we'd have too small an amount. We'd only have the 78 pounds. So we need to over shop. We need to shop for 128 pounds so that after the trimming, we still have the 100 pounds we need. Okay so far? Either thumbs up in your video or with your Zoom thumbs up. Okay, Alex is quiet, but I'm going up anyway. So if you're not used to the fact that division makes things bigger, then here's a little picture to help you remember. When your scale factor is between 0 and 1, right? These numbers are between 0 and 1. They're all percentages less than 100%. Then if you multiply, it shrinks it. We saw that on the first time. And if you divide, it makes it bigger. Normally we do math with numbers bigger than 1. So we're used to multiplying, making things bigger, and division, making things smaller. But if we're multiplying or dividing by a tiny thing, the opposite happens. Okay, we have our steps. We can actually do complete kitchen math now. So a recipe that makes 28 servings requires 5 pounds of carrots. How many pounds of carrots should you purchase if we're scaling it up to make 105 servings? And if carrots cost 75 cents a pound, what will the carrot part cost? Everyone okay with this multiple part question? Okay, so like eating an elephant, we'll just do it one bite at a time. We're going to start with scaling up the recipe. So that was a proportion. We have 28 servings in 5 pounds. If we want 105 servings, how many pounds should we shop for? I'm going to use the shortcut just because I'm low on screen space. So we'll multiply the two that are opposite each other as numbers, divide by the one opposite the y. And we get about 19 pounds. Part 2. Do we need to change anything? No, pounds is still good. Sometimes we would want to change from tablespoons to cups or from quarts to gallons or something, but this is still a reasonable amount. Okay, step 3. We have to take yield percent into consideration. If we only shopped for 19 pounds of carrots, then by the time we trimmed them, we'd be too small. So let's take our 19 pounds trimmed. Look for carrots. There they are. So we're going to divide by the 0.81. Because 81% is 0.81. And what do we get? About 23.4 pounds. So I'm going to round it up to half a pound. Then 4, how much are we going to have this cost? Well, it cost 75 cents a pound. The problem tells us that. So I get $17.59. Questions on any of that?
The 2, one that says that no need here. Can you explain what that's asking?
Sure, let me see if the next one does need it. That's also pounds. Let's imagine that there's a recipe that starts out at sort of a home kitchens thing, and it says put in a teaspoon of cinnamon. And when you scale it up to make the same pumpkin pie recipe for 300 people, you're not going to want to measure your cinnamon in teaspoons anymore. Right? You'd be spooning little bitty teaspoons all day long into that pot. So sometimes you'll say, oh, actually, instead of teaspoons, I want cups of cinnamon or something like that. So that's what they're talking about. Okay, if we were actually in the classroom together, I would have told you, today, bring in a fruit or vegetable, and I would have some fancy electric kitchen scales, and we would have found out some yield percents ourselves and done some practical stuff like that to help you remember. But oh well, I can't get you access to my little kitchen scales. You can always try this yourself. Have everyone at home cut an apple and see what percentage of the apple you keep to eat and what percentage is the core that you compost, and see what differences are. Okay, so now we have 10 more problems for the food preparation section. As always, work on them without peeking at the multiple choice answers first, and then when you're done, you can turn them in by using the link, and at the end you get a code. There are some classmates that are doing great and have at least 8 out of 10 on multiple homework assignments so far. So if you want help, let me know. I can always say tomorrow at 2, would people who have done well on homework show up for the study session to help their classmates. At the end, we also have random exercises. If you need more practice or aren't sure that you're getting things right, then there they are. When you reload the page, the numbers change and the answer key updates. There's a cute little interlude from Factfulness where he talks about things, and the lesson is there's a size instinct, check your proportions, which relates to what we just did with checking proportions. So that's it for health decisions. If we look at the very bottom of the table of contents, then there's a health decisions test. So let's go there and look at that. All this is the random problems from throughout the different topics of health decisions. So this one you won't recognize because we skipped patterns, but the rest should look familiar if you've been working through all the problems so far. Part of my job as Math 25 teacher is to make sure you don't forget too much Math 20. So this test starts with a bunch of Math 20 problems, and it says do 3 out of 10. So just a little bit of nagging, pick 3 of these that you think are easiest and get good at those. You don't have to know how to do all 10. It's not like you have to be a perfect Math 20 student anymore, but you can pick 3 out of the 10 and get quick at them. And then work on, for the actual Math 25, do 12 out of 14. So you can all skip number 1 because we haven't done patterns yet. If you want, it's not that hard to learn it at home. And then try at least doing 12 out of these 14. Since it's a practice test, you have your answer key here and everything should be happy. Someday we'll actually do a midterm. And the best thing to do is use our in-class midterm time to do cooperative work, because it's really hard to do that as homework. And maybe even we can schedule it in a way that lets some of the people whose work schedules make our normal class time not working, that they can get some midterm cooperation. If it doesn't work in class, then I can just say, yeah, eventually we'll have you do one of these at home. Take pictures of your scratch paper and send it to me. It's important to do some midterms because otherwise at the end of the term, when you have a practice test, that's going to be the first test you've done, and just that how to take a test will feel weird and everything like that. So it's important to do some that are not important, like the final, just so the testing itself doesn't seem strange by the time we get to the one that matters. If you look at your achievement list, then achievements. Some of the achievements are about test taking. Remember that you want to get half of the achievements in each category plus a few, so you don't actually have to do well on any overview. But if you get 70% or more on the health decisions practice test, then you can get a star. And if you ace it, then you get another star. If you don't want those, you can do these other little quizzes instead. But since the final exam will have exactly these kinds of problems on it, you might as well get used to them. Okay, so we are now, except for patterns, which we could go back and do or could just ignore it, all done with health decisions. Any last questions since it's 3:29?
I do have a question about the book reports.
Okay, go there. Book reports. What's your question?
So I know that at least one of them is on the first chapter of Factfulness, but I can't seem to remember what the second one is supposed to be for, and if it's due on this at the same time as the first one.
Do at the end of the month, same time. So go to the library, the heart-shaped page here.
Okay.
And then in the red box, click on book reports. And that gets you the description. The second one is a business reaction. Since pretty much everyone is forced to take Math 25 for business reasons, culinary or nursing or social work or something, then pretend you have a small business and make it so small that you don't really have any employees. That might be easiest just to work with. And be creative. It doesn't have to be realistic. And read a little bit of your book. It says your hour, 3 chapters. Those are guidelines. For a specific book that you borrowed, top one, I might guide you to 3 chapters that aren't the first 3 chapters. That would be the most meaningful. Not all books start with the most interesting stuff.
Okay,
And
so this would be for the second book we borrowed, not Factfulness.
Right, the other one you borrowed.
Okay.
And then just answer these 6 questions. How does its math apply to your business? How does it help you see the world? What habits does it try and teach you? How does it fit on the page? Some paragraphs along with math, things like that.
Okay. Is there like a word limit or page limit on the
No.
reports?
Now, the goal here is that whoever is hiring you in the future wants to know you can take other people's math and understand it and talk about it with somebody else. So can you communicate other people's communicating with math? Because that's something you have to do on the job in real world. So it could just be a page if you can answer these well. It could be longer. I don't care. Whatever makes your explanation flow well.
Okay.
Any other questions? No? Okay, well, thank you for class. See you tomorrow at 2 or 2:30. And have a good rest of your day.
Thank you. You too.